Since we have now introduced stream processing, let's get started on some of Samza's terminology. A core concept in Samza is an idea of a stream. A stream is composed of multiple messages, usually of the same type or category. One example of a message could be a page view tracking event on Kafka. User logs into his account, views a page, and that generates a tracking event which lands on Kafka. Another example of a stream could be a sequence of updates to a database. At LinkedIn, we have a system called Brooklyn that lets you model a sequence of updates to a database as its own stream. Now, getting to a more formal definition, we'll see that a stream is a partitioned, ordered, replayable collection of immutable messages. I see that there's a lot of words here that are of interest, so I'll dissect them one by one. Partitioned. For scaling how data in it is processed, each stream is broken down into one or more partitions. Think of each partition as an append-only log. If you write a message to the stream, it lands up in one of the partitions of that stream. A nice property of this is that the partitions themselves are independent and don't share any state. Hence, data in these partitions can be completely processed in parallel. In case you're wondering, how is partitioning decided? Partitioning is typically determined by the producer of the message based on some key in the message. For example, if it's a Kafka topic that tracks page views, the producer can partition individual messages by user ID. The next property of a stream that we look at is ordering. As we saw earlier, a partition was an append-only log, and each message in a partition has an offset which is unique per partition. So you can think of each offset as a sequential integer or a byte offset or anything even like a string that uniquely identifies a message in a partition. While messages within a partition are ordered by an offset, it should be noted that there is no ordering across partitions. Replayability. Another nice property of a stream is what we call as replayability. As we just saw, each message in a partition is associated with an offset. This means that a consumer can provide the offset of a partition that it wants to consume from, seek to it, and replay messages from that offset. Immutable messages. Each message in a partition is associated with a key and a value. This means that once a message is written, it cannot be modified later. However, you can append new messages to the same stream. A message that's appended to the stream typically lands up in one of the partitions of the stream. One of the key design goals for Samza is pluggability. So Samza allows for different systems to define and implement what their own notion of a stream is. As a concrete example, you can think of each stream as a topic in Kafka and each partition as a topic partition in Kafka. Some other system like HDFS can model each stream as a directory of files and each partition as its own individual file. You can implement what we call as producers that write data to the stream and consumers that read data from a stream. Each stream can have multiple consumers, and reading a message does not delete it from the stream. Out of the box, Samza integrates with and has built-in producers and consumers for Apache Kafka, AWS Kinesis, HDFS, Elasticsearch, Azure Event Hubs, and Brooklyn. Also, it's actually quite easy to add your own new integrations. So far, we have seen what is a stream, what are producers, and what are consumers. We have all this data in the stream, and now it's time to look at what can I actually do with this data. We'll illustrate this with a motivating example. Imagine you're a social networking website, and each page view that a user did, you generate a corresponding event. So the page view event and its structure is quite simple. It contains a user ID, the user who viewed the page, the URL of the page that got viewed, the location in which the page was viewed from, and the device in which the user viewed the page from. Here are some interesting things that you can do with the stream of page view events. Let's say I only care about iOS devices. In that case, I can filter them by device type and write it to a different stream. If I only care about a subset of fields in the message, I can extract them and generate a new message and write the message to a different stream. In this case, we are only extracting 2 fields out of the 4 fields in the message. Alternately, I could also count the number of daily unique users that visit my website from a stream of page view events. As you can see, a few of these operations, like filtering a message based on some field or transforming a message based on some type, for example, these do not require state to be stored in the system beyond the current message that's being processed. We call these operations as stateless operations. On the other hand, the use case of counting the number of unique daily active users requires us to track if you have seen the current user for deduping at a later stage. It also requires you to store a count per unique user. We call these as stateful operations, primarily because they require some state to be stored in the system beyond the current message that's being processed. Samza provides world-class support for both these operations. For building stateful operations, Samza provides a state store that's fault tolerant. A nice thing is that Samza takes care of all the hard stuff like data partitioning, fault tolerance of your state, recovery of your state, handling failures, checkpointing, while you can just focus on building your application. Now that we have gone through what is a stream in Samza and why we need state in stream processing, we are ready to discuss the next concept of what is a stream application. We refer to a stream application as any application that's written and developed using the Samza API. A Samza stream application typically reads from one or more input streams, processes the data or transforms them, and emits them to an output stream or a database. Samza provides you with 3 APIs to help you build your stream applications. The first of this is the Streams DSL. The Streams DSL supports multiple built-in operators like map, filter, etc. This is the recommended API for most use cases. There is also a low-level API which provides a per message API and allows for greater flexibility to define your processing logic, offering greater control. And then there is Samza SQL, which offers a declarative SQL interface to create your applications. Thanks for watching this video. To recap, we defined the need for stream processing and what is Samza, and we also introduced some terminology around streams, state, and stream applications. In the subsequent episodes of this course, we'll take a closer look at how Samza works under the hood. Thank you.